Visible even from space, these underwater kingdoms cover less than 1% of the ocean floor.
Yet they harbor 25% of all marine life, and every single millimeter was engineered by tiny, soft-bodied animals.
Welcome to the coral reef, the most complex, biodiverse metropolis on planet Earth.
At first glance, a reef looks like an underwater forest of carved stone. But this is no rock formation. It is a living architecture, continuously constructed by trillions of individual organism units known as coral polyps.
Relatives of jellyfish and sea anemones, most stony coral polyps are no larger than a grain of rice.
How can creatures so small build structures large enough to deflect oceanic storm waves?
The secret lies in an extraordinary biological partnership that began hundreds of millions of years ago. Through photosynthesis, these microscopic algae harvest sunlight, supplying the polyp with up to 90% of its energy needs. In return, the polyp provides shelter and essential nutrients. Using this solar energy generation after generation, polyps build atop the skeletons of their ancestors, creating vast three-dimensional habitats. Different species grow into distinct shapes: plates to catch light, branches to withstand waves, and boulders for endurance.
This structural variety creates thousands of distinct ecological niches within a single square mile.
Every crevice is prime real estate. Crabs, gobies, and moray eels occupy the lower stories of. Meanwhile, grazers like parrotfish keep the city clean by scraping away competing seaweed with their beak-like teeth. In fact, much of the pristine white sand on tropical beaches passed through the digestive system of a parrotfish. Apex predators like reef sharks patrol the outer walls, maintaining balance across the entire food web. When sun sets over the ocean, the reef undergoes a dramatic shift in behavior. Under cover of darkness, polyps extend translucent tentacles armed with stinging cells to hunt microscopic plankton.
And on specific nights of the year, usually after a full moon, the entire reef orchestrates a miracle.
Synchronized across hundreds of miles by lunar cycles and water temperature, mass coral spawning begins.
Simultaneously, millions of corals release buoyant and sperm bundles into the water column. This underwater blizzard ensures genetic diversity and allows coral larvae to drift and seed distant reefs. Survivors settle on bare rock, transform into a single polyp, and begin building a new city from scratch. For millions of years, this engine of growth has endured. But today, coral reefs face a threat faster. As atmospheric carbon traps heat, ocean temperatures spike. Even a rise of 1 degree Celsius.
When water's warm, the delicate symbiosis inside the polyp breaks down.